Section 8.1, example 7, locating the foci of a whispering chamber. A large room in an art gallery is a whispering chamber. Its dimensions are 46 feet wide by 96 feet long. So the dimensions that we have right here. And in a whispering chamber, if you stand in the foci, which are these two, if you stand in the foci, your voice travels, bounces off, and ends up in another foci. You don't have to scream, you don't have to do anything. It literally just sounds as if you're standing right next to the person. It's actually pretty cool. But for the sake of this problem, let's see what they're trying to figure out. What is the standard form of the equation of the ellipse representing the outline of the room? So what I want to do is imagine this being on the origin. So that way the center is the origin. We go out so many units here, here, up, down. So let's figure that out. So let's give ourselves enough room. That's right. Okay. So what is the standard form of the equation? So let's write standard form out just as is. X minus h squared over a squared, y minus h squared, or y minus k squared over b squared equals 0 equals 1. All right, so if we make the center the origin of the room, the origin, then we immediately get rid of h and k. So we could start out with our x squared over a squared plus y squared over b squared. All right, now from here, if we go out from the center, we go out this many units. Actually, it would be half of that 96 feet, so it wouldn't be the full 96. So what's half of 96? So 2 times 48. So 48 feet from the center, and let's do the same thing over here. That's 2 times 23. All right, so from the center, we go out 48 units here, we go out 48 units here, we go out 23 units here, 23 units here. I feel like that's really good, but we're going out those many units, we still have to square them. So let's just plug these numbers in and figure out what that equation ends up being. Our x squared over, let's see, x ends up being our major axis, so we're good there. So x ends up being 40, or a ends up being 48. So we're looking at 48 squared plus y squared should be 23 squared, just to make sure. Yep, 23 squared. And this all equals 1. Let's figure out what those numbers are. So we have our x squared over 48 squared. Where's our square? There we go. Squared, that's 2304. Plus our y squared, 23 squared, 529. And there we go. So that is our equation there. So far this is what we have. And now if two visitors standing at the foci of the room can hear each other whisper, how far apart are the two visitors? So really what we're looking for is the distance between these two. We know that the distance between here and the center is going to be what C is. And we just have to multiply that by 2 to figure that part out. So let's grab our equation. Let's figure out what C is. So what we want, we want 2c. And we could figure out what c is. We just have c is equal to the square root a squared minus b squared. So c in this case is that 2304 minus 529. And then finding out the square root of that number. So that minus that. All right, that gives us 1775. Does this give us a nice root? Nope, it doesn't. All right, so we could say that c is approximately 42.13. All right, so that's c, but we want 2c. So since c is equal to, well, c is approximately 42.13, our 2c is going to be approximately, just multiply that by 2, 84.26. Do they tell us round to the nearest foot? All right, so the nearest foot is just going to be 2c, approximately 84 feet. So now let's answer the question. So if two visitors standing at the foci of the room can hear each other whisper, how far apart are the two visitors? So the two visitors are about 84 feet apart. And there we go. That's our solution there. Hope that helped. And of course, if you have any questions, please feel free to ask. Otherwise, bye.